as we explore logs, we get to the point where we're going to have a certain type of log that we use more often than others. This is called the common log. The common log is where we look at a logarithm that doesn't list a base on it, and that base is going to be base 10, just like our number system is base 10. So our objective is that we can understand and use common logs, but let's start by going back and reviewing over logs with other bases. So we'll start with some review problems. First of all, if we're asked to simplify these or to evaluate these, what my recommendation to this is to set it equal to x so we can set up an equation. Remember that the answer to a log problem is the exponent. So this is saying 2 to the x power is equal to 16. So we're asking, what do you put 2 to? What power do you put it to in order to get that 16? Well, if you put 2 to the 4th power, you get 16. So x is equal to 4. So our answer for log base 2 of 16 is 4, because 2 to the 4th power is 16, and the answer to a log is the exponent. So let's try this next one. This next one, if we set it equal to x, again, and set it up as an equation to solve, 12 to the x power equals 144. We're trying to figure out what exponent do you put 12 to get that 144. Well, 12 squared is equal to 144. So our x, when we have the same base on both sides, the exponents have to be equal. And so we set x equal to 2. So this is just a reminder of how we can use exponential equations with the same base in order to find out what the value of the logarithm is in some of these instances. Now let's do one with log base 7. Again, if we set it equal to x, we do 7 to the x power is equal to 1 over 49 as we circle back over to this one. Now we've got to figure out, when you have a denominator, what does that do with our exponent? We know that 7 squared is 49, but when it's in the denominator, that makes it a negative exponent. So 1 over 49 is the same as 7 to the negative 2nd power. So denominators, negative exponents. Now we have the same base on both sides. We can set the exponents equal, so our answer is negative 2. And this last one over here, we set it equal to x. We're going to set it up as an equation. 5 to the x equals 125. 5 to the 3rd power is 125. So with the same base, our exponents are equal using our rule. So our answer here is 3. So this is reviewing over, when you have different bases, how you evaluate these and how you use this technique to find out and simplify them. Now let's go to the case where we don't have any base at all. So what I want you to think about here is, when we've done problems before, we've had, for instance, when we just list an x. We list an x, that's implied to be x to the 1st power. We don't put the 1st power there, it's implied to be there. Same with the root. So when we do a root problem, if we've got, say, the square root of x, well, that's implied to be the 2nd root of x. So 2 is the known index when we don't list an index on our roots. So the question then is, what is the base on a log when it is not listed? That's the question we're going to answer here. So if we have a log, and we have log of, let's say, x here, and there's no base listed here, what you need to know is that's called the common log. The common log is log base 10. So when no base is listed, the base is a 10, okay? So when no base is listed, it is base 10. That is the critical idea here to gather from this lesson is that we have it base 10. Now, our calculator recognizes that. Our calculator has a log key right here. That log key, when we list it there, that is log base 10. It doesn't list a base on it, so it's log base 10. So when you look at the log key on your calculator, and you see that on the left side of your calculator, this is a base 10 key, log base 10. All right, so let's look at these problems. We're going to talk about them without a calculator and with a calculator. So if I'm doing this with a calculator, I want to do log of 10,000. You just pull up your calculator, you hit the log key, and so you hit log of the 10,000, and that's going to give you a 4. The answer to it is 4. Now, why is it 4? Why is that answer 4? Well, let's talk about it without a calculator and what that means. Remember, this would be log base 10 of 10,000. To simplify this, set it equal to x. Let's set up our equation. So this is 10 to the x is equal to 10,000. Now, your question you're asking then is 10 to what power is 10,000? Well, if you remember probably from your science classes or when in math you did scientific notation, the way you figured that out is you counted zeros. 1, 2, 3, 4. That's 10 to the 4th. And so x is equal to 4 when the bases are the same. So we get our answer of 4 from working through it without a calculator. Let's look at this one. Let's use the calculator first. Log of 0.001. So if we do log of 0.001, okay, that is equal to a -3 with a calculator. Okay, nice and simple for that. Now, why is that? Again, you might remember from the working with scientific notation that if you move the decimal over to the past the 1, that's -3 places, we get that 10 to the -3rd is equal to 0.001. So the answer to a log is that exponent for it. So that's why we get -3. Again, you could set it up like this and simplify similar to what we just did. And then this last one points out that there are going to be many problems that you can't do it without a calculator or with a table of some type. This type of problem, if we set it up like this, we would not know what the answer is. Let's reason it out real quick. This is saying log base 10 of 105. Well, 10 to what power would be equal to 100? Well, 10 squared is equal to 100. 10 cubed is equal to 1,000. 105 is somewhere between that 100 and that 1,000, so the exponent has to be somewhere between 2 and 3. So when we do this, we're going to have to do it on a calculator. And so we get log of 105, gets me a long decimal point. And so what I'm going to do is I'm going to go ahead and put 2.02 as my answer, just rounded. Now, rounded is not exact. We're going to sometimes have to round answers, and that's what the calculator does. But we can check it out by just saying, let's put 10, we're going to put 10 to the power of the answer, which we have stored in the answer button down here, second answer down here. That stores this whole decimal, and notice when I do that, it tells me that 10 to that power is 105. It uses a little rounding to be able to do that, but if we had the exact number, it would give me 105. So what we have to recognize is that there's going to be certain logarithms that we use more than others. The first one that we're learning about is going to be the common log. Common log is base 10. So when you see a log that does not have a base listed, there's no subscript, the base for that is 10, and we have to take that into account when simplifying, solving our problems, and recognize that on our calculator we have a log key that we'll be able to use and will help us with these problems.